hyperbolas shown here. If you notice, they're very similar to our ellipses. The only difference is that they are subtraction in between instead of addition, right? Okay, so here we've got x minus h quantity squared over a squared minus, here in the middle we've got a minus y minus k quantity squared over b squared equals 1. And we can tell that our major axis is the horizontal, right? Because the a squared was under the x. Okay, over here, we've got y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. So in this case, instead of swapping the a squared and b squared, we actually had to swap the numerators, because with addition, the order didn't matter, right? But with subtraction, the order will matter. So we got to make sure that we're putting the y minus k squared in the first fraction, okay? But as long as y is over the a squared, we'll have something running vertically, right? Okay. So it goes over the orientation, so which axis is their major axis. When a squared is under x, it's horizontal. When a squared is under y, it's vertical. Your center is still hk. You still find your vertices from your h plus or minus a or your k plus or minus a, because your A is still going to give you the vertices on your major axis. So depending on which axis you're on, that's the one that you will be adding or subtracting your A value to. Okay, and then your foci are going to be the C values, just like before. And your C and A are on the same axis, just like before. Okay, and then it says your transverse axis is y equals k. Your conjugate axis is x equals h. Those are just your lines. And then it says your asymptotes. So if you guys notice, mine up here are red in the picture. These diagonal dotted lines here are the asymptotes of these graphs. It says that this is how you find them. For a horizontal, it's the equation y minus k is equal to plus or minus b over a times x minus h. Okay, this also is commonly written as y equals plus or minus b over a times x minus h plus k. So basically, they just took the k and moved it to the other side of the equation. So it was like a y equals equation. So that way it's easier for you to graph it, right? Okay, same can be said over here. Okay, the only difference when it's on your vertical axis is that instead of b over a right here, we have a over b. That's the only thing that will change. Also can be written as y equals plus or minus a over b times x minus h plus k. So really just taking k, moving it to the other side of the equation. All right, and just like before, c squared is equal to, but in this time it changes just a little bit because they're facing the other direction, a squared plus b squared. You guys see that it's a squared plus b squared instead of a squared minus b squared. So it changes just a little bit because instead of my two ellipses facing each other, right, and connecting, they're facing the opposite ways. So your A and your B kind of switch around there, okay? So now they're facing outward. Basically took two ellipses and flipped them the other direction, or cut it in half and flipped them outward, okay? All right, so now that we have the equations and we know how to find the pieces, let's do an example. Example 1 says to find the center, the asymptotes, vertices, foci, and then graph the hyperbola. Okay, well, we can easily see h and k here. What are my h and k, or where's my center? 0, 0, all right, because there's nothing in those numerators. Good. Okay. Now, was the first fraction x or y in the numerator? Y. So does this one run vertically or horizontally?
Vertically.
Vertically. Okay, so we know that this one's going to run vertical. Okay. And we know that the first term is always going to be over A, right? So that makes this my A squared and this my B squared. So a little bit different. The A doesn't have to be the bigger one, right? Okay, so if A squared is 9, then what's A? 3. And if B squared is 25, what's B? 5. And then remember they said that C squared is A squared plus B squared, right? So C squared equals 9 plus 25, which is what? 34. So C squared equals 34. Okay, and that's not really going to simplify, right? There's nothing that multiplies to give me 34 that has a square root, so C is square root of 34. Okay. So we know our center is at 0, 0, and whenever we go to plot our other points, we know we're going to run vertically. All right, so it says to come up with the equation of the asymptotes. So if you look back here, that would be this equation, right? Y equals plus or minus A over B. So for us, this would be Y equals plus or minus, what would our A over B be? Right? Okay. Times X minus H. Well, what was our H? 0. Plus K, and what was our K? 0. All right. So in other words, this is really just plus or minus 3/5 X, right? So that means it was not shifted up or down any. And our slope tells us to go up and over 3/5 and then also down and over 3/5. So up. All right, so there's one of my asymptotes. And then we're also going to have one with the opposite slope, so one slanting the other direction. All right, so there's our asymptotes graphed. It then asks about the vertices. Well, if you look back up here, we said the vertices in this column, the H stays the same. We add or subtract A to the K value, right? So H stays 0. I add or subtract my A value to K. Well, my A value was 3, right? And my K value was 0. Well, 0 plus 3 would be 3. 0 minus 3 would be negative 3, right? So we're going to have vertices here at 3 and here at negative 3. All right. And then remember your foci say that you're going to add and subtract the C value, right? Okay, well, C was 34, square root of 34. So I can't really add or subtract the value 34, right? I mean, the square root of 34, since I don't know what that decimal exactly is. So I'm just going to put plus or minus square root of 34, all right? Now, when I go to graph it, I do want to know approximately where that would fall, right? So the perfect square root right below that would be 25, right? The one right above it would be 36. So the square root falls between 5 and 6 then, right? Okay. It is between 5 and 6 somewhere. It actually is approximately 5.7, so we're pretty close with that estimation. So I'm going to go a little bit more than 5 up and a little bit more than 5 down and plot those points there. And then I'll just draw my hyperbolas. So remember, you won't actually touch the foci, so it just looks something like this. All right. Okay. Let's flip it over and do example 2. Same idea. Okay, so just like with our ellipses, we always want the equation, if you look at the front, to equal 1, right? So how can I fix that here? What am I going to need to do? Divide everything by 64. Good. Okay, so every single piece I'm going to divide by 64. Okay, so 16 over 64, that's going to simplify down to a denominator of just 4, right? So I'm going to have x plus 2 quantity squared over 4. And then negative 4 over 64. So in between here, I'm going to have a minus, right, since it's negative. And then this would be 16. So y minus 3 quantity squared over 16 equals 1. Okay. All right, so now this time my first term has x in the top, right? So that means this one is going to run horizontal. Yes, on our x-axis. Okay. So remember, the first term is always a, not necessarily the bigger one. So if a squared is 4, what's a? And if b squared is 16, b is 4, right? And then remember, c squared is a squared plus b squared. So 4 plus 16, so 20. So c would be square root of 20. Which you could simplify a little bit. You could simplify this to 2 square root of 5. All right, perfect. Okay. So, looking at our simplified equation that we came up with right here, what are my h and k? Where's my center? Good. Okay. And then for my asymptotes, remember, if you look back at the front, this is going to be the equation y equals b over a this time, right? The fraction flips over according to the equation on the front. So if I put b over a, that's going to be 4 over 2. And 4 over 2 simplifies to just 2, right? Times x minus h. And what was our h? Right, so minus negative 2 will really just be plus 2 in there, right? Okay, and then plus 3 for our k value. Okay. All right, if you want this in slope-intercept form, we could distribute, right, and then combine like terms if we wanted to. Or you can just remember, okay, this is a shift from 0, 0, right? Whichever way you want to think of it. So I'm going to go ahead and plot my center, which was at negative 2, positive 3. Okay, so I know that this line has been also shifted over 2 and up 3, right? And going to have a slope of 2, right, in either direction. So up 2 and over 2 in the positive direction, and then also down 2 and over 2 in that other direction. Sorry, down 2 over 1. Okay, so we've got our asymptotes drawn. Now we need our vertices. Well, since I'm running horizontally, this time instead of adding my a value to k, I'm going to add and subtract my a value to h. Very good. Okay, so my h was negative 2, and I'm adding or subtracting 2, right? So if I was at negative 2 and I add 2, that's going to put me at 0, 3, And if I'm at negative 2 and I subtract 2, that's going to put us at, right. So we've got vertices at, Yes.
Is the center off or the graph off?
The center off.
The center's
Oh, yes, it is. I started at the wrong spot. I graphed my asymptotes wrong, didn't I? Sorry. Yes, that's still my center at -2, 3. But that should be where the asymptotes cross, is at -2, 3. I apologize. I started too low. Okay, there we go. Now that my asymptotes are crossing in the appropriate spot. Okay, so at 0, 3, I have a vertice. And at -4, +3, I have a vertice. Okay? Now I need to find my foci, which again, our major axis is running horizontally, right? So I'm going to add and subtract C to the H value. So my H value, again, was that -2. But this time we're adding and subtracting a square root. I don't expect you to know perfectly what that would be. So we'll just write it as -2 plus or minus 2 square root of 5, 3. All right, and then 20 would be in between the perfect roots of 16 and 25. So it'd be 4 point something, right? Around 4.5 is approximately what that would be. So from the center, I'm going to go over 4.5. And from the center, I'll go this way, 4.5. So our graph looks something like this. All right. Okay, let's do another one. This one says we're going to find the equation. They gave us all the points. So instead of us deducing the points from the equation, we're going to deduce the equation from the given points. All right, so we've got vertices at 4, 1 and at 4, 9. Okay, well, if my vertices are at 4, 1, oh, just kidding, I plotted those wrong. Sorry, 4, 1, that one was right, and 4, 9. If my vertices are on this vertical line, right, that tells us that we have a vertical hyperbola, which means that y goes in the first fraction and x goes in the second fraction, right? Okay, so we know that it's going to run vertical just based on where those points are. Okay, and where should the center be? Direct middle of those, which would be at what point? 4, 5. Nice. Okay, so we also now know the center to be at 4, 5, which is our H and K, right? Okay. All right, and then the distance from the center to the vertex is going to be my what values? A. And how far is it between the vertex and the center?
5.
Is it 5? 1, 2, 3, 4 places, I think. Yeah. So our A value will be 4. Okay. All right, then we also have foci at 4, 0 and 4, 10. So right above and right below, right? And foci is my C value, okay? So my C value is what? 5, And then we would just need to figure out the B value. Okay, well remember, C squared now equals A squared plus B squared, right? where we now know c squared to be 25, a squared to be 16. So what would our b squared be? Yes, b squared would be 9 when we subtract, okay? So b would have to be 3. Okay. So now it looks like we've got all the information we would need in order to come up with the equation. So, it's going to look something like this. We don't need the asymptotes to be able to write the equation, so we won't worry about finding them. That would just be an extra step. So, we said that the y would be first, since it was vertical. So it'll be y minus k, which was, good, quantity squared, over a squared, which would be, right, minus, good, over 9, right, since it'll be b squared, equals 1. Bless you. Okay. We got, I think, one more to look at. Let's flip it over. Let's look at this last one together. Okay. So this one is going to pull it all together. It says we have to complete the square in order to put it in standard form. Then we identify the center, asymptotes, vertices, and foci so we can graph. All right. So we're going to have 25y squared plus 100y minus 16x squared plus 96x equals 444. Okay, I rewrote it in this order because remember we do want there to be subtraction between the two terms, right? So we are going to put the y's first and the x's second. All right, so we've got 25y squared plus 100y. So we're going to probably want to factor out 25 from that, right? Which would leave us with y squared plus 4y, plus blank. So in that blank, what am I going to put? 4, right, 2 squared, or 4, Which means also I'm going to add that over here as well. So it'd be 444 plus 25 times 4, right? Okay. Then we got minus. In this next term, we're going to want to pull out a 16. So that'll leave me with x squared plus, what's 96 divided by 16? 6. Oh, I pulled out a negative, didn't I? So that should actually be minus 6x plus blank. Okay. So now I look at that negative 6. I half it, which would be negative 3. I square it, which would be 9. And then over here, I'm going to add negative 16 times 9, right? Okay, so now we're going to simplify. We've got our coefficient of 25, and that first term can be rewritten as y plus 2 squared. Very good. My second term has the coefficient negative 16 and can be written as, x minus 3. Quantity squared. Very good. Okay. All right, and then over here we've got 444 plus 25 times 4, which is really just 100. So that'd be 544, right? And then what is 16 times 9? We can do it without a calculator. That'd be, okay. All right. So So minus 144. So what's 544 minus 144? 400. So this all equals 400. All right, but we want it to all equal what? 1. So what are we going to do? Right, divide everything by 400. All right, so 25 over 400 would simplify to 16, right? So I'd have y plus 2 quantity squared over 16 minus 16 over 400 would simplify to 25, right? So x minus 3 quantity squared over 25 equals 1. All right, now that I've got the equation, I can find all the other things, right? So first of all, where is our center? Okay. So we got -2. Oh, wait, we flipped it around. Flipped it around, yeah, because it's y first. So it'd be 3, -2. Yeah, because remember, h is the one with y, and k is the one with x. Okay. All right, now I just need to know my a, b, and c. Okay, well, a is always the first fraction, right? So if a squared is 16, then a must be 4, right? And if b squared is 25, b is 5, good. And then c would be 16 plus 25, which is, right. So c is going to be square root of 41. Again, not going to be a perfect square root, but it falls in between 36 and 49, so it's got to be approximately 6 point something, right? Again, I'm not going to be checking your graph to see if you're closer to one number than the other. So as long as you give me a decimal in that range, you're good. Okay. All right. Now for our asymptotes. Okay, well, y was first, right? So is this going to run vertical or horizontal? Vertical, okay? And when it's vertical, remember your equation for the asymptotes is plus or minus a over b, right? So a over b for us would be 4 over 5, good, times x minus h, which we said was 3, good. Oops, not quantity squared. Okay, plus k, which was, okay. All right. All right, and then for our vertices. For our vertices, we are going to be adding and subtracting a, and we're running vertically, so I'm going to add and subtract a to h or k? K. So I'll have 3 that stays the same, and our a value was 4, so what's -2 plus 4? 2. And what's -2 minus 4? -6. All right, and then your foci would be on the same axis, right? So again, h stays the same, but I'm going to add and subtract c to k. So that would be -2 plus or minus square root of 41, right? Okay, so let's graph this. We've got a center at +3, -2. And then our asymptotes obviously go through that center and have a slope of 4/5. Okay. All right. So asymptotes are something like this. And then we've got vertices at +3, +2, and at +3, -6. And then you have foci at 3 and then -2 plus or minus around 6-ish, right? Okay, so we'd have something at around 4 something, so somewhere in here, and then also down here at like a little past -8. So this one would look something like this, and this one would look something like this. All right, so it's pretty much the same as your ellipses, but instead of the two facing each other, they face opposite directions. So that just changes a couple of tweaks to some of our formulas.